starting today, our focus for the rest of this chapter, which is going to be broken up into two parts, all right? Actually, with what we're going to be doing today and then tomorrow, and then we're going to bring the first half of the chapter to a close and for the rest of the week, and then we're going to look at the other parts of the chapter later, next week. And the thing is because this is a large chapter, there's a lot of things you really need to know. But this starts the solving of quadratic equations, all right? Finding out where where a graph hits the x-axis. So we've got 5 different things we're looking at doing that. The first one we're doing today, and that's with graphing, and we're also going to bring a table into that also as we're working with it. Tomorrow we're going to do factoring, which you've done factoring, but we're going to solve the quadratic equations with factoring tomorrow. Then we're going to do what's called completing the square and the quadratic formula. All right, so there's 5 ways to solve quadratic equations. Graph or table, those are 2. Factoring, quadratic formula, completing the square. And we're going to look at all 5 of them in the course of the next 2 weeks. All right. So first thing, to be able to solve a quadratic equation, it has to be equal to 0. So if it's not set up so that it equals 0, one of the steps we have to do is make sure that it does equal 0. So regardless of what you see, we always want it to look like this: ax squared plus bx plus c equals 0. Now notice that they went from this here to here. Okay, doesn't matter which side the 0 is on. No. Okay, it doesn't matter what side an equal sign is on. Okay, whether it's on the left side or the right side, it's easier to get in the habit if we always have the equal sign on the right hand side that we're working with, and so that it's equal to 0, so we put the 0 on the right hand side of the equal sign. So first of all, with graphing, so we want to write the related function, graph it, and then find the zeros. But we always want to make sure that it is in the form of ax squared plus bx plus c equals 0. It's got to always be in that form. All right? So letter A. We're going to graph and find the zeros. 2x squared minus 18 equals 0. So first thing, all right, is if there's a greatest common factor, okay, if there's a greatest common factor, even if it says to graph it, okay, I want you to divide by that to start with. Okay, as far as if it's a number, greatest common factor. So these both have what in common? 2. So we're going to divide everything by 2. Okay, both sides. So we get x squared minus 9 equals 0. Okay. All right, so we're going to graph this. So what do we need to be able to graph it? We need to know the axis of symmetry and the vertex and the y-intercept, okay? So we need to know those 3 things. So basically the vertex, axis of symmetry, y-intercept. So first of all, let's work on the vertex, all right? Now we talked about this the other day, didn't we? What's the value of b here? 0, okay? So if the value of b is 0, what's the axis of symmetry? Okay, so the axis of symmetry then is x equals 0, all right? Okay, so If I put 0 in here for x, what do we get? What's 0 squared? 0. And 0 minus 9 is? All right, so our vertex is going to be 0, negative 9. All right, so I need to change my picture here. Got it. Okay, because my vertex is at 0, negative 9. Okay, now, well, that's also my y-intercept, isn't it? Right? The vertex is my y-intercept, so that makes it tougher to graph. And so this is where knowing about quadratics comes in handy. Okay? What is the value of a now? What's the value of a here? 1. Okay? So this is how it works then for all of them when the value of a is 1. It goes over 1 both ways, and it goes up 1. Okay? All right, so let's look at this. All right, I'm talking about stuff. Let's make it happen. All right? So if I made a table, all right, here's my x, here's my y. Okay? I have 0, negative 9 part of my table. Okay? So I'm going to go to 1 and negative 1. Okay? If I put 1 in for x, right, we get 1 squared. And 1 squared minus 9 is negative 8. Okay? So we have at 1, negative 8. Okay? Which means that I also have to have negative 1, negative 8, right? Because here's my axis of symmetry. Okay? So I want you to understand that, because all I'm doing is from the vertex, we are going 1 left and 1 right, which means since the value of a is 1, that means you'll go up 1, because it behaves just like x squared at that point. Okay? So if we go over 2, well, what do I get when I square 2? 4. So that means I'm going to go over 2, go over 2 from my vertex, 2 to the right, and I go up 4. 1, 2, 3, 4. So I have a dot there. And if I go over 2 to the left, I go up 4. Okay? Unfortunately, I'm still not to the x-axis yet. Okay? So I squared 1, got 1. Squared 2, got 4. So what's the next number? Okay, so if I square 3, what do I get? 9. Okay, 3 squared is 9. So from the vertex, I'll go over 1, 2, 3 to the right, and up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right on the vertex, or right on the x-axis. 3 to the left, up 9. All I'm doing is using the fact that x squared, when I square 1, I get 1. When I square 2, I get 4. When I square 3, I get 9. Just using that basic feature of x squared. Right? So what's my answer to this problem then? Where is this graph going to cross the x-axis? Okay. All right, at positive 3 and at negative 3. So if I draw the graph now, looks like this. And so how can I check that? Make sure my graph's correct. Everybody put in your calculator y equals, let's do the original, y equals 2x squared minus 18. Put that in your y equals. Okay. Is it going to look the same? Unfortunately, it's not going to look the same. Okay? But it's going to cross the x-axis at the same spot. Okay, so I want you to understand that. It's not going to look the same, but it's going to cross the x-axis at the same spot. All right? And what's our goal here? Make sure it crosses the x-axis at the same spot. Okay? Positive 3 and negative 3. Right. Why does it look different? Anybody know? Because we divided by 2 to start with. Okay, it looks different because we divided by 2 to start with. Right? So our answers, positive 3 and negative 3. Right, we're trying to find where does it cross the x-axis. Right, so your graph's got to get there. Okay. All right, let's look at another one. Negative 12x plus 18 equals negative 2x squared. So it has to be equal to 0. So would you rather that your a value was positive or negative? Okay. Positive or negative. We always, if we can, we want it to be positive. So for this problem here, we're going to add 2x squared to both sides. Right? Because we want everything on the left side of the equal sign. And we want the x squared to be positive. So we have 2x squared minus 12x plus 18 equals 0. Don't combine the 2x squared and the 12x. Those are not like terms. Okay, I know some of you want to. All right, don't do that. All right, so graph that in your calculator right now. All right, we're going to do it by hand, but I want you to see it first. Okay, all right, first of all, which way does this graph open? Okay, up, because A is positive, right? All right, so we know that. It's got to open up. Okay. Where's the y-intercept? Where's the y-intercept? It's right there. Where is it? Okay, positive 18, right? All right, so I've got some work to do on my graph here. I got to change this a little bit. Oops, go the other way. There we go. Okay, so we know it opens up. We know the y-intercept is going to be positive 18. All right, so I'm going to put a dot there and positive 18. Yes, Michael. Why didn't I divide by 2 this time? Just haven't gotten there yet. Okay, this time I'm not going to because I want you to see it without doing that too. Okay, I want to do both. I know I said to do it, didn't I? Okay. But let's look at it because not everybody's going to remember to do that. So we'll look at it the other way. All right, so our vertex. So we need to find the axis of symmetry. Negative 12 over 2 times 2. So we have, how many negative signs do we have? 2 of them, which means we're going to end up with a positive. Thank you, Courtney. So we get 12 over 4 is 3. So our axis of symmetry is going to be x equals 3. Okay, awesome. Put in 3 for x. And if I type this in my calculator, so we're going to put 3 in for x then to check for the y value for the vertex. 3 squared is 9. 9 times 2 is 18. So we get 18 minus 12 times 3 is 36. Plus 18 equals, oh, hey, that's nice because that actually does equal 0. So the vertex is the point 3, 0. Well, that makes things easier. So I put a point at 3, 0, and if it's opening up, how many times is it going to cross the x-axis or touch the x-axis? Okay, just one, and it's going to be right there. So I went, so if here's my axis of symmetry, all right, so here's where we got to fix that problem you guys had. Okay, some of you now want to draw this graph this way. Okay, but since A is positive, you already told me it opens up. So here's my vertex, here's my y-intercept, so I have to go, I went over 3 and up to 18 here, so I've got to go over 3 and up to 18 there to draw the graph. And by the way, this is not a V. Okay? I think I took a point off from somebody because they drew a V on Friday. Okay? You got to have some circulation going there. Okay? It's got to be curved. All right? So what's my answer? How many zeros are there? 1. All right? And what's the solution here? X equals 3. Okay. All right, and we're going to do those graphically. I want to see them graphically. Okay, you drawing the graph on your paper correctly. Okay, let's do one more. So just a reminder that we are solving equations. So even though we're drawing these graphs on our paper, we're solving equations. So our answer to letter A was plus or minus 3. The x equals plus or minus 3 because that's where it crossed the x-axis. Okay. Our answer here, x equals 3 because that's where it touched the x-axis. Okay, so we got x squared minus 4x, or x squared plus 4, 2x squared plus 4x equals negative 3. I'm struggling, Gary. Okay. So what's the first thing we need to do? Okay, we need to add 3 because we want it to be equal to 0. So we get 2x squared plus 4x plus 3 equals 0. Now in that last problem, Michael said, hey, we need to divide by 2 because you said to do that. All right, well, I didn't do it that time. Okay, this time can we divide by 2? Okay, we cannot because 3 is not divisible by 2, so we're not going to do it here. All right, so we need to find the axis of symmetry. Opposite of B over 2 times A. Find the axis of symmetry first. So 4 divided by 4 is what? 1. So we get negative 1. There was one negative sign, and 4 over 4 is 1. Okay. A couple of you made that error on the other day that you end up with 6 over 6 at one spot and just said it was 6. Okay. All right. Make sure you simplify that. All right. So we put in negative 1 to find our y value for the vertex. So negative 1 squared is 1. 1 times 2 is 2. 4 times negative 1 is negative 4, plus 3. So 2 times minus 4 is negative 2, plus 3 is positive 1. So our vertex in this case is at negative 1, 1. All right. What's our y-intercept? Okay. Y-intercept is positive 3. All right. So we went over 1 to the y-axis and up to 3. So we need to go over 1 the other way, up to 3. And then we can draw our graph. Now here's the thing. Okay, as soon as I knew where the vertex was, I knew there was no real solution in this case. All right, because if the vertex is above the x-axis and it opens up because A is positive, there's no way it can go back down, right? Right, Sebastian? Okay. All right, so there's no solution here. Because the graph is never going to cross the x-axis. So graphing it correctly makes a big difference. So you got to make sure that you graph it correctly. Make sure that when you're putting the vertex there and the y-intercept, that you make sure you go the other way, okay, from the y-intercept to get that other point. So always verify that you've graphed it correctly, opening up or opening down. Okay. All right, so I want you to do all right, negative 16x squared plus 20x. Zoom 6. All right, now, I don't care if you show me, well, yes, you should show me a rough sketch of the graph. Okay? So on your paper, you should put a rough sketch of this graph. Okay? And this is a situation where that you don't have to be perfectly accurate right now, okay? The ones before they should be accurate. These don't have to be perfect. Like I said, though, tomorrow when we're doing the factoring and solving these equations, right, it'll be easier. The question is, how long is the dolphin out of the water? Okay. So let's see. We have crosses the x-axis at 0, right? And then over here between 1 and 2. Okay. Looks like the vertex is 1, 2, 3, 4, 5, 6. Approximately 6 and about 1/2, right? Right. So you should draw a graph that crosses the x-axis at 0, crosses the x-axis a little past 1, goes up to about 6, okay, with your graph. All right, you should look pretty close to that. Now, the question is, how long is the dolphin out of the water? Okay. Well, let's look at our table for a second. That's one of the things we haven't looked at yet. Let's look at the table. So second graph takes you to the table. So we can see that it equals 0 at 0, right? Okay, we knew that. At positive 1, it's 4. At positive 2, it's negative 4. Right? The other number I care about is when it equals 0, correct? Okay. But I can't see that, can I, here? So I need to try to find that. Anybody know how I can find it? All right, good. We're going to figure it out. All right. Press second and trace on your calculator. Second and trace. And we want to find out where it hits 0, where it's equal to 0. So select number 2. Okay. Now they want a left boundary here. All right. So we're trying to find this spot here where it hits 0, at this spot just past 1. Okay. So for a left boundary, we want to be at a spot that's left of that 0. Okay, for left boundary. Doesn't matter where it's at. It does in a way. It can't be to the left of the other 0. It can only be left of the one we're looking at here. So since I'm to the left of that, but not the other one, I can hit enter there. Right? So move your cursor to the right a little bit, hit enter. And there should be a triangle that shows up on your screen, right? Okay, if you're using one of the colored ones, it'll put a dotted line there too. But if not, then it just puts a color. Okay, so then take your cursor past the 0, past the spot where it crosses the x-axis. Okay, so I go down here to negative values. Okay. Or you could even type in a negative value, since I know that positive 2 is past that spot, I could actually just put in 2 and hit enter, and it'll actually do it also. Okay. So you should have 2 triangles on your paper or on your calculator. Where it crosses the x-axis should be between those 2 triangles, and now if you hit enter, it will give you that answer. So the question was, how long is a dolphin in the air? And the answer is 1 1/4 seconds. Okay, 1.25 seconds. Or out of the water. Okay. Okay. Answer the question. All right, so let's see. 1, 2, this is about 6. So my graph looked like this. All right. And this number here is 1.25. Okay. So it was out of the air or out of the water for 1.25 seconds. Okay, getting a nice breath and then going back down. All right, so let's look at another one. All right. A frog. We all like frogs. Okay. They're good at hopping. Okay. A frog jumps straight up from the ground. The quadratic function f of t equals negative 16t squared plus 12t models the frog's height above the ground after t seconds. About how long is the frog in the air? Okay, so put that in your y equals. Negative 16x squared plus 12x. Right. Graph it. Should look very similar to the last one.
I didn't have the same numbers as yours did.
Okay, go to second window, right, and change your table start to 0, and change in table to 1. Yep, the triangle. Yep, there you go. And I'll go there. And I'll go to your table. I'll do it. There you go.
Thank you.
Okay. All right. Yes. That would be this one. I'm doing this one. Okay. Okay. So, all right. Now here's what our graph looks like. And how long was the frog in the air? Well, it looks like less than 1 second, right? Okay. Okay. He didn't go very far. Okay. Must be a weak frog. All right. Doesn't have good, strong frog legs that you would want to cook and eat. Okay. All right. So we need to figure out where does it hit the ground. Okay. I already know it's 3/4 of a second. Okay. And we'll learn that tomorrow with factoring, probably. Yeah, we will. Okay. So second trace number 2. Okay. So this was a little bit harder because my window is so big, and you could make your window smaller. So we'll just do this, okay? So our left boundary, we want to make sure that we are to the left of that spot, all right? Hard to see it there, you can do it. Hit enter to make that left boundary. Okay, now the right boundary, it can be any number I want. I could put in 10, okay, or 8, or 7, or anything I wanted to. It just needs to be to the right of that spot, okay? So I'm going to put in 5. Okay. All right, look at that. My y value is negative 340. It doesn't matter because where is it? It's to the right of that 0, okay? I can't pick any number I want to the left of it because I can't have both the zeros there, okay, in my window that I'm looking at, okay? Then hit enter, and it tells you it's 0.75. So that frog was in the air for 0.75 seconds, or 3/4 of a second. Okay. All right. Now you could also find that by graphing it by hand too. A little bit more difficult there though. Okay.